All right, I'm going to talk about branch-chained alkanes. And first of all, what is an alkane? An alkane is a hydrocarbon made of hydrogen and carbon, and it has only single bonds between the carbon atoms. Obviously, there's only single bonds between the hydrogen and carbon atoms as well, but that's what it is. Okay, so this right here is what we call butane, right? Because you have four. Look at our reference tables. Q and reference table P. We have four carbon atoms in this, and so that's a butane, if I just had it like that. Now, a branch, if you have a branch off of this, it would be like putting a carbon, you can put a carbon off of one of those main spots, okay? Now the name of this one right here, what do we name this guy? I'm going to tell you. This is still a butane. So what we're going to do is I'm going to do this twice. I'm going to show you how to name it in two different ways. And we're going to get the same name, but we'll do it a little differently each time. Okay. So the first step is you want to find out what the longest continuous chain of carbon atoms is. So it's right here. I'm going to just highlight it. It's 4 carbon atoms. The bottom one, we could also do that. We could go like this even. We're allowed to like turn, because in 3D it would actually look the same if we did it with the modeling kit, right? So now we notice that there's this little branch hanging off of the main chain, as you will. Okay, so we call this group, this little group, because there's only one atom in it. This is called, oops, that's not the one I want. This is called a methyl group. Why is it a methyl group? Because when we look at the reference tables, there's only one carbon atom in that group, and meth is corresponding to one carbon atom. So that's why that's a methyl group. So the way we would name this is methyl butane, because we have the main group and then that one. Actually, now that I remember, I was going to color code this so you could see it. So methyl, and then use the other color, butane. It corresponds to the different parts of that. All right, let's make it a little more complicated, or just add more information. This isn't really that complicated. Okay, so let's say we have 1, 2, 3, 4, 5. Now I'm going to go like this. What type of a compound is this guy? Like, what's the main chain, the longest continuous chain that we... Oh, I didn't just flip my... Okay, there we go. What is the longest continuous chain? I'm not going to put the hydrogen atoms on there because they're not super important when we're naming them. It's easier to see it this way. They take a long time to write on there. So the longest continuous chain here is our 5 carbon atoms, right? And again, we can see that we've got a methyl group hanging off here and a methyl group hanging off here. But this time, so this is a methyl, oh wait, jeez, come on, Methylpentane. Again, it's from here. We've got 5 carbon atoms in the main chain, 1 in the branch. So we say methylpentane. We can also go, this is also methylpentane. However, this time we need to pay attention to what carbon atom it's off of. And so on we want to have the lowest number. So if we were to number the main carbon atoms from 1 to 5, we should go like this. If I did it the other way, then you'd have that methyl group off of the 4 carbon, and we don't want that. We want it to be the lowest number that it could possibly be, so it would be 2. So we're going to name this 2-methylpentane. Down here we've got 1, 2, 3, 4, 5. This is 3-methylpentane. Okay? Now it's possible to have even more side chains, or side chains on 2 things. So watch this. I could go like this. So now I've actually got 2 side chains. Got one a methyl one up here, and another methyl over here. And now, this is how we name this guy. We're going to, again, assign numbers to the carbon atoms. So it's going to be 1, 2, 3, 4, 5. In this case, we write 2, 3, and because there are 2 of them, we use the prefix di, dimethyl, and then pentane. So it's 2,3-dimethylpentane. I'll do another example. So these, it's really just example after example here. What if I have this? Oops. I'm going to move that down a little. Okay, and we're going to do this in 2 different ways as well. For this one, we can actually do a couple different ways. We can look at it in several different ways. Okay, so the first thing you do is you find the longest continuous chain. And that would be, you would think it'd just be this, right? However, this carbon down here is part of that chain. So as long as you can go in order, that's what it is. 1, 2, 3, 4, 5, 6. And then you could also go like this. That's 6 as well. Guess what? We're going to get the same name for both of those. Okay? Let's look at our side chains. First of all, we have a methyl group here because it's 1 carbon, another methyl group. This other group, though, right here, I'm going to do it in red. Wow, that's kind of crazy. That is an ethyl group. Why is that an ethyl group? Because it has 2 carbon atoms in it, and when you have 2 carbon atoms in it, we use the prefix eth. Okay, so that's going to be an ethyl group. And then we've got the methyl group over there. So this name is, let's number these first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I don't remember, but I think they're supposed to go in alphabetical order. So I think the ethyl group goes first. So it's going to be, it's a 3. So let's go with this. 3 ethyl. And then we put a dash between it. 3 ethyl, 2 methyl. Methyl, and in this case there's 6, so it's hexane. And that goes for the other one as well. I can't do that way. Okay. I'm just going to copy and paste that. Yay! The same compound. All right, we'll do one more. So you can see a combination of a bunch of these different things. So C. Okay, so this one is kind of crazy. But we like that. Okay, so longest continuous chain is this. We can let's number them from, let's see. We'll number them from this side. Since our first one is off of the 2, if we go from this side, 1, 2, 3, 4, 5, 6, 7, 8. So we know, first of all, that we're dealing with an octane. Because oct is our prefix for 8 in a row. All right, and then let's look at our side chains. So first of all, we've got a methyl group, a methyl group, and a methyl group off of our side chain. And then we also have, right here, we have a ethyl group. Okay, so we're going to do the ethyl group first. I hope that octane is in the right spot. It's going to be squeezy. Move this stuff over. Okay, so we'll do our ethyl group first, and we'll start with the carbon it's off of, 4 ethyl. And now we've got a whole bunch of methyl groups. So we're going to list those numbers off, and it's going to be 2, 6, 6. You have to say the 6 twice. 6, 6. And then it is, because there's 3 of them, it's trimethyl octane. So it's 4-ethyl 2,6,6 trimethyl octane. Okay. Now, going from a number or from a name to a compound, you should be able to do that. That shouldn't be too difficult, I don't think, right? So if I did an example, I would be like, quick example would be like, let's see, 2, 3 dimethyl methylpentane. First of all, a heptane is going to have 7 carbon atoms. So you just draw those out first. 1, 2, 3, 4, 5, 6, 7. And guess what? I don't care if you put the H's. I really don't. It's just assumed that the H's are there. All right. 7, and then 2, 3. So we're going to put a methyl on the 2 and on the 3. There you go. There's your 2,3 dimethylheptane. And that's the end of this video, and I hope that I'm making the ending long enough for you guys. So have a great day. Bye.